So we're on the start of the climb where Brian was crushing. And then right in here from Jason's feet down to the water bar, that should have all been dug down 6 to 8 inches below with that material brought up and bermed up here. So here we're at the wooden water bar at the top of the pitch. All this material needs to be dug here and then brought down here and covered over here. And you can see extending out without the capping material, a bunch of this stuff has been kicked and dribbled. But the idea here is when the trail comes around, we want the drainage to go low, deeper than it currently is, and then all that material brought over here. This is a section of D-berm up the hill. While the material was taken down, there was no shaping with the treads, so the grade comes like this and then flattens out where the water can stay on. All right, so at this water bar, the improvement here would be extending the funnel up into where Jason is and tilting the trail and then following the line with opening it up, allowing the water to curve off the trail well before. In this scenario, the water stays in the trail and then turns at this crux. Also here, there was a good use of putting material upstream or uphill in front of the root. That's great. It creates a berm, but the actual low point that could be compromised, we are neither 6 to 8 inches below the grade, nor did we berm up this material right here. So here we have a drainage at the bottom of a pitch. There's probably a prescription for de-berming. Again, from the toe of the trail tread downhill, material scraped off, but that transition and shaping in the de-berm of getting the outslope of the trail did not get accomplished. In fact, here the trail inslope, so water is going to continue down this path. This simple drain has a great ending to its ditch. The material is brought back for the berm. The only concern here is we still have the hockey stick angle, and it's kind of narrow at the opening right there. Ideally, we'd cut this material, flop it back, so as water comes down here, it stays and goes this way and doesn't come here to drop sediment. On this drainage here at the bottom of this, before the grade change, it was good to have the material brought over to build it up, but again, our weak spot is the 6 to 8 inches below the grade. So this is only a few inches right there. Water, once that's clogged, will go down the trail. This drainage has a really good depth to it for the existing trail, and its intention was to take all the water that was in the rock garden and have it divert off the trail versus going onto the flats. That was good. This little drainage kickoff on the uphill side of the rock garden achieved the objective. We got good depth, we got good width. The berm was created, it allows the water to come. The only improvement would be to increase the direction of the drainage, maybe going through that rock so that it keeps it in a straight line, and then extend the berm up along the side of the trail. But good on depth and width. This is a drainage at the bottom of a pit near the old, or a pitch by the old boundary line. This one is not nearly deep enough. That drain is considerably higher than the downhill side. From a shape standpoint, it does a good job of wanting to divert the water, so it's not a hockey stick. We would just be looking to get it deeper and bring that material down. So this is a drainage. Some of the drainage have small little up and down berms. This area downhill of the trail, that material can be brought into the berm, and also bringing the funnel into the trail tread so that the water tapers out is the better scenario for the long-term health. But the reason we took this video is we don't want to have these small little berms that go up. We want to extend them out. All right, in this drain, we have a really good depth that they dug, and then they clearly patted in from the dirt where Jason's going to stomp, and that's great. The only opportunity for improvement here is we've got no disturbance in the actual trail tread. This is really good to keep that straight line versus the hockey stick, but if we kind of brought all this material and brought it uphill of that rock, would have just taken it from like an 85 to 100. Here's a section to be debermed. Obviously there's an opportunity for water to get off the trail. We just want to remember we need to shape the tread a little bit. Right here along this line kind of represents those short little berms behind the drainages that we don't want, in addition to this one being not 6 to 8 inches below. So part of the benefit of having that depth is that any scouring that happens is in the compacted, undisturbed soil, but also you get that material to recover and put back on the trail and extend the berm. So higher up we have another old wooden water bar on top of some rocks, and we've got a drainage that they cleaned out, which is generally good. It keeps the direction. There was no hockey stick here. That's great. The challenge is that up there, during a high water event, water's still going to be able to get over this and go through. So extending the funnel actually into the trail tread to capture, and then having this a little bit deeper, would have allowed more material to create a berm between the rock and the wooden water bar. Just above that, we have these series of crib steps water bar combos. So this is an old log triangle. So we're kind of fixed with the structure, and we're just putting the dirt in below. Here, we would have wanted to, again, be deeper and bring that material up onto the triangle, and to the extent we can, dig the drainage onto the hinge side of the trail and extend it up, folding material over, and also allowing that to be a straighter shot for the water.